Welcome to a new exercise. This time we're going to go back to this train chase, but this time there will be a time delay between the two trains. So let's have a look. A train leaves the station moving in a straight line at 80 kilometers per hour. A second train departs from the same station 30 minutes later at 150 kilometers per hour. Find when and how far from the station the second train will pass the first one. We'll start by identifying the relevant quantities that are given in the problem. The speed of the first train is given is 80 kilometers per hour. The delay between the two trains is also known as 30 minutes. That means one train is traveling for 30 minutes before the other one starts. And we also have that the speed of the second train is 150 kilometers per hour. So the second train is moving much faster than the first one, so at some point it will catch up and will pass the first train. The question is where this will happen. Okay, so now that we have the relevant quantities, we draw our cartoon, and as usual the first step is choose coordinates. So we draw our now standard arrow indicating the x-axis. We mark somewhere the origin so that the origin is located at the same point where the station is. So here is the station. This is the station from where the two trains will leave. The first train moves at velocity v1 and the second train moves in the same direction with velocity v2. Second train will pass the first one somewhere here, and we can call that coordinate d. That means the distance d from this station. So this is basically the cartoon of the situation. Now we can write the equations. The position of the first train is given by its initial position plus v1 times t1. The initial position is 0 because that's how the coordinates have been chosen. So we get v1 times t1. So this is the coordinate of the first train. For the second train, we can write x2 to be the initial position of the second train plus v2 times t2. Again, this term is 0 because the two trains start from the station that we simply chose to be at coordinate x equals 0 at the origin of the system. And there we have it. Two equations, two trains. Now we move to the step in which we want to set the conditions that the two trains will be at the same position. In other words, when the second train will pass the first train. So this is what we can call the passing point. Passing point. There is where the two trains will have exactly the same coordinate. So at the passing point, we know that the coordinates must be the same. So the coordinates of the first train must be the same as the coordinate of the second train that we simply call little d. We don't know what little d is yet, just call it little d. In the previous problems, we said also the next part of the condition that refers to the time. We usually said there that t1 is equal to t2, and we call that t. Here we cannot do that, because t1 is the time that the first train has been moving, whereas t2 is the time that the second train has been moving. But since there was a delay between the two, we cannot set them to be equal, so we have to be careful. How do we do that? Well, we know that t2 will be a little bit less than t1, exactly 30 minutes. So this is the instead of t2 being equal to t1, what we have is that t2 is t1 minus 30 minutes. For the sake of units, and in fact this is very important, just as in previous problems, we found that the units of length were different. Here the unit of time is different because the velocity is given in kilometers per hour and the time delay is given in minutes. So we have to transform these minutes into hours. So this is the same as T1 minus half an hour, 0.5 hours. So now we are in the same units, so we're fine. That means all units will cancel properly. Okay, so we have T2 being equal to T1 minus half an hour. I will simply call this T for simplicity, so T2 will be just T, and T1, solving from this equation, T1 is just T2 plus half an hour, or just T plus half an hour, because T2, we're just going to replace it by T, just to avoid this subscript. And that's it. We have our condition. We can impose this condition in our two equations. So for the first train, we have x1, which we know now is simply called d, is v1 times t1, but t1 is this, t plus half an hour. We can expand this to be v1t plus half an hour times v1. So this is what we get from the first equation from the first train. From the equation of the second train, we have that the position, or the coordinate, is d, is v2 times t. So from the first equation and from the second equation, we take the right hand side and we set them to be equal. So we can write v2 times t is the same as v1 times t plus half an hour times v1. We pass this term with t to the other side, and we get minus v1t equal to half an hour times v1. Now we collect the common term t, so we factor t. v2 minus v1 is half an hour times v1. And now we simply divide by this term in parentheses, so we find that t is half an hour times v1 divided by v2 minus v1. And now we can plug the numbers. So we get 0.5 hours times v1, which is 80 kilometers per hour, divided by v2, which is 150 kilometers per hour, minus 80 kilometers per hour. And now we put these numbers in the calculator. We have 0.5 times 80 divided by parentheses 150 minus 80, and this is 0.57. So we can simply write this as 0.57, and the units will all cancel properly. Kilometers per hour will cancel the kilometers per hour, and we get this in hours. Here we are being asked about the one, a little bit over half an hour after T2 has left. Because don't forget, this quantity here, little t, is T2. 0.57 hours after T2 left. If you want to know the time with respect to T1, so when the first train left, we just need to add 30 minutes, because we know that T1 is just T2 plus half an hour. So this is closely, a little bit over 1 hour after the first train left. We also being asked here about the how far. So what is the distance from the station? This is little d. And for that, we can use any of the formulas we have derived. I will put a little square here to finish that part. So if I use this equation over here, I can write little d to be v2 times t, where v2 is 150 kilometers per hour times t, which we just found to be 0.57 hours. So let's see how much this is. 150 times 0.57, 85.5. So we can round that up to 86 kilometers, because the unit of time, hours and hours, will cancel. So this is little d. So that's the distance from the train station where the second train that is moving faster, but it started half an hour later, will catch up and pass the first train.